All right, I'm working on side 2 of the practice test. I decided that I'm not going to work through all the problems. I'm just going to try to take some sample problems and work through them, but then I will hopefully still be able to give you the answers so you can look at them and correct any mistakes you've made. But 13 through 16, you're supposed to be using the quadratic formula, and so I picked one that I thought would be a little bit harder, I guess, 15. Remember, when you're solving using the quadratic formula, you have to get everything on one side or it won't work. So it's not like completing the square where I can get like the y's on one side, the 12 over here. No, just get everything together. So I'll start by moving the 14y's here to the left side. So now I got minus 14 plus 12 equals 0. Now I do have, just for sake of full disclosure, a calculator off here that you can't see, it's on screen, but I've got one. And for a problem like this, you're probably going to want to have a calculator unless you're really good at multiplying, which maybe you are. Okay, so the quadratic formula is negative b, I'll go ahead and write it. Be a good one to memorize though. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. The beautiful thing, once again, about the quadratic formula is the quadratic formula always works. All right. So I have a minus 14. So what's a minus 14? That is a positive 14. There's my b term right there. Plus or minus b squared. Now I think 14 squared is 196, but I'm going to go ahead and check real quick. Like I said, I've got a calculator off to the side here. Yeah. So b squared minus 14 times minus 14 is a positive 196. Remember that. It's going to be positive. Right. Minus 4 times a, so a is 5, and c is 12. And then it's all going to be divided by 2 times a, which is 5, right? So it's 2 times 5, that's going to be 10. But let's go ahead and simplify this part over here. So 4 times 5 is 20, and then 20 times 12 is 240. So this is actually really interesting. Maybe I shouldn't have picked this problem, but here's what we're going to end up with. 14 plus or minus square root 196 minus 240. So I can pretty much stop this problem right now because I know, I don't even know, it's going to be negative 44, right? But even if I didn't know that, the fact that it's a negative number means there's going to be no solution because you can't take the square root of a negative number, or at least the solution's not going to be any real number. So 15 looks like no solution. But anyway, that's how you do it. You set it up, and then I guess the hardest part for some of these problems is just simplifying that part in there. But like I said, since I got to, I can go ahead and write it just so it's clear. But that would be this once I simplified it, and that means there's no real solution for that one. All right. Next, I'm going to look at number 18. So 18, they give us a quadratic equation, 3x squared plus 2 equals 7x. And now they want us to evaluate the discriminant and state the number and nature of the solution. So remember, the discriminant is this part of the quadratic formula right there. The discriminant is just b squared minus 4ac, 4ac. All right. But still, if you're going to find the discriminant, if you're doing anything with the quadratic formula or the discriminant, you've got to get everything on the same side. So 3x squared minus 7x plus 2 equals 0. All right. B squared in this case is going to be 49, right? Because negative 7 squared is 49. Okay, and then that's minus 4 times a, which is 3, times c, which is 2. So 4 times 3 times 2 is 24. So I've got 49 minus 24. And so that's going to be a 25. Look at that. It's a perfect square. Okay. So if I have something, so that was the first part. It wants to know what is the discriminant, and we just found that. The discriminant is going to be 25. Now it wants the nature of the solutions. So if I have a perfect square like this, it's going to have two solutions, two rational. And we'll review in class what the other types are as well, but just real quick, if the discriminant happens to be 0, which that's the case sometimes, that means you have one rational solution. If it's not a perfect square, if it's something that, like, maybe you can simplify it, but it still has a square root, like, so for example, the square root of 24, right? If I had something like the square root of 24, you can simplify that, but it's still not going to be a rational number. It will still be an irrational number. And so you're going to have two irrational solutions. If you have something that's not a perfect square, like square root of 24, like square root of 17, whatever, that stuff doesn't give you perfect squares, so the solutions will be irrational. And then if the discriminant's negative, it's no solution. But for this one, we got a perfect square. Square root of 25 is 5. So we're going to have two rational solutions. Okay. Moving on. Let's see. Number 20. They give us the solutions. Okay. They say that x equals negative 2 and 2/3. And they want us to write a quadratic equation that would have these for the solution. So it's like we're working backwards. We want to, and they ask to write the equation in standard form. Now that's key. So let's just remember real quick. Standard form is ax squared plus bx plus c equals 0. Now here's why I picked 20, because 20 has this fraction here. So really what we want to do is we want to think of factors, right? We want to think of expressions that, like, okay, so for example, one of the solutions is negative 2. So whatever this quadratic is, it's going to have a factor that x is going to equal negative 2. Right? What would that factor be? Well, you can tell really quick, it's going to be x plus 2, right? That's got to be one of the factors. Because if I plug in a negative 2, it's going to go to 0, and that's what we want. We got our quadratic equation in standard form, it equals 0. So if I have a factor here, and it's going to be multiplied by another factor that I don't know yet, but it's going to equal 0, that means x plus 2 has to be one of the factors if one of the answers is x equals negative 2. Now, with the 2/3, it gets a little bit trickier, right? So we know that one of the solutions is x equals 2/3. Well, how do you get a factor for something like that? And here's what we can do. I'm going to just go ahead and move this 2/3 over to the left so that I get x minus 2/3 equals 0, which is basically what I want, right? And then I'm just going to ask, okay, if I want to get rid of this 3 in the bottom, what can I do? And the answer is simple. I can multiply everything by 3. Because if I do that, I'll get 3x minus 3 times 2/3 equals 0 times 3. Right? And then what happens? Well, what's 3 times 2/3? These 3's undo each other, and then I'm just left with 3x minus 2, and then 0 times 3 is just 0. So there we go. There's my factor right there. It's going to be 3x minus 2 Now, this is important, that's not the final solution, right? Because they said that they want the equation in standard form. So now all I have to do is take these factors that I found, x plus 2 times 3x minus 2, and I'm just going to FOIL that. So x times 3x, that's going to be 3x squared, right? Then I have x times a minus 2, so that's minus 2x, plus a 6x is going to give me 4x. And then finally 2 times a minus 2 is minus 4. So there is my solution right there. And if I wanted to check, just real quick, let's say I'm taking a test, and I want to make sure that that answer is correct. What I could do real quick is just say, okay, well, let's see if these solutions work. And I'll just pick minus 2, because I think if minus 2 works, it's a good chance the other one will as well. So let's just plug that in real quick. If I have 3 times a minus 2 squared plus 4 times a minus 2, or a negative 2, minus 4, what will I actually get? Will I get a 0? Well, let's see. Negative 2 squared is 4 times 3 is 12. 4 times a negative 2 is a minus 8. And then we still got a minus 4. Okay, well, 12 minus 8 is 4. And 4 minus 4 is 0. Sure enough, negative 2 works. I'm pretty sure if we plugged in 2/3, it would also work. So those look good. Okay, so last one I'm going to look at real quick is 21, where they give you a function, a quadratic function, and it looks like this. F of x. So this is 21. F of x equals x squared minus 2x minus 3. And the first thing that they're asking you to do is find the zeros. And so let's go ahead and do that first. That's the first part, that's what 21 is asking you to do. So when does x squared minus 2x minus 3 equal 0? Because that's what finding the zeros means, right? And this is the same thing when you're drawing the graph. These answers are going to be where the graph crosses the x-axis. First thing we want to ask, especially since the leading coefficient is 1. When the leading coefficient is 1, you should always begin by trying to factor it. Hold on, I'm going to take a drink of water real quick. So there are two numbers that when I multiply them together give me minus 3. When I add them together give me minus 2, and the answer is yes. If I have x minus 3 times x plus 1, when I multiply negative 3 times 1, I get a negative 3. When I add negative 3 to 1, I get a minus 2. And so I can see immediately what my zeros are going to be, right? If x minus 3 equals 0, one of the answers is going to be 3. There's one of my zeros. And then when x is negative 1. Now, since they're asking for zeros, I'm going to go ahead and write these answers as coordinate pairs. So my first 0 would be 3, 0. And my next one would be negative 1, 0. Now, this question is going to go on to ask, they're going to ask you to graph this. And so let's go ahead and take the function, because what you would probably want to do since you're going to graph this is you'd want to put it in vertex form so you can see what that vertex is going to be. So I'm going to go ahead and do that. This is actually problem 23 where they ask you to state the vertex. Well, 22 asks you to write it in vertex form, so let's go ahead and do that first. Or they call it graphing form. So what we want to do is complete the square of the function here. So we're going to add something to it, and then we're going to immediately subtract it, and that way we'll be able to see what the vertex is really easily, okay? So remember, when you're completing the square, you do negative 2 divided by 2 squared. So that's negative 1 squared is 1. Just going to add 1 here. I'm going to subtract 1 there. Now remember, this right here is now, I'll go ahead and group it, a perfect square. And if you want to know how to factor a perfect square, you just take the b term and divide it by 2. You get x, and then you're going to have that term there squared, and to get that term right there, you just take the bx, or the b, and divide it by 2. So x minus 1 squared, and then negative 3 minus 1 is going to be a minus 4. So now that this is in graphing form, I can just look at this really quick and see, oh, the vertex is going to be 1 minus 4. And now if I'm asked, so that's actually 23 is asking what is the vertex. So that's going to be the vertex right there. And now to graph this would be really straightforward, because all I'd have to do is plot the vertex and plot these two zeros. I would have 3 points and be able to draw the graph.